I've got a vector question worth 9 marks in total over 3 parts. It says in part A that OACB is a parallelogram, and it gives us OA and it gives us OB in a diagram. In part A, we have to show that cos of the angle is equal to this funky expression minus 2 root 5 divided by 25. So let's do it. So the first thing I'd be looking at here is that O to A and O to B form a triangle if we draw a dotted line down here. Main thing we're going to do in the question is be able to find the angle here at O. So I'm going to label this on. But what I'm going to do first is I'm going to find the vector AB, which is the dotted line. So we should know that if we're looking for a vector AB, then we're going to go from O to the second vector minus O to the first vector. Luckily for us, we've got OA, we've got OB as given in the question. I'm going to do it as a vector, as a column, but you can do it as i's and j's as well. So 4 minus 2 is 2, and then minus 7. And then I write it as the ij format here at the end. So if that's AB, then I'll write that on the diagram. Specifically, it's going down, but we'll see it doesn't actually make a difference in this question. These arrows were also in the diagram, but I just missed them out. So what I'm looking at here is that OAB is a triangle. And if we're thinking about a triangle, you might be thinking about, well, we've got 3 sides of a triangle, we can use the cosine rule, so we're going to find the lengths of each of the sides. So if I find the length of OA, it uses Pythagoras' square root of the first number squared and the second number squared, and we get root 20. OB is similar, square root of the I component squared plus the square root of the j component squared. In this case, we get root 25, which is 5, which should make sense because it's basically a 3, 4, 5 triangle. Nice Pythagorean triple. AB is a bit nastier, it's the square root of the I component, which is 2 squared, and the j component, 7 squared, which gives root 53, not so pleasant. So with this, now we can apply the formula. So by now, hopefully the cosine rule should flow off your tongue. A squared is b squared plus c squared minus 2bc cos a. And the a's have got to be the side and the angle opposite each other. So we're going to take root 53, we're going to square it, and it's going to be equal to root 20 squared, and it's going to be equal to this plus 5 squared minus 2 lots of root 20 times by 5 times by cos of a, which is the angle we're looking for. Now, root 53 squared is 53, root 20 squared is 20, and 5 squared is 25. So altogether that gives 45. And then we're going to minus, well, 2 times 5 is 10, and root 20 I'm going to simplify into root 4 times root 5, and root 4 we know is 2. So all in all, this is 10 times by 2 root 5 cos a. If we subtract 45 from both sides, we will get 8, and if we times 10 by 2, we'll get 20. With the minus sign, root 5 cos a. Now if we want cos a, then we can simply divide by this minus 20 root 5, and we'll get 8 over minus 20 root 5. I'll bring the negative to the top, and I'll divide numerator and denominator by 4. And then I will rationalize the denominator to get minus 2 root 5 over 5 times 5, which I'll do on a new line because this is our final answer, minus 2 root 5 over 25, which is exactly what we wanted to show. Okay, now we've got the 5 marks out of the way, what's left? So part B is asking us to find the exact value of sine. So this is less a vector question, more of a trig question. Well, if we know what cos is, then we should be able to find out what cos squared is. And the reason I'm going to get you to find cos squared is because then we can use the cos squared formula that we know and love. So cos squared, I'm going to square numerator and denominator. 20 in the numerator, and I'll write it as 25 times 25 so I can simplify. So if I now divide numerator and denominator by 5, I'll get 4 over 25 times 5, which is 4 over 125. So the formula, the identity that you should know, is that cos squared plus sine squared is equal to 1. That's true for any a, any value inside. This means that if we want sine squared, it should be 1 subtract cos squared. And we know what cos squared is. It says it right there. So we're going to do 1 subtract 4 over 125, which is 121 over 125. If that's sine squared, then of course we combine sine, because we can square root it. That means sine is going to be the square root of that, which is plus or minus. Square root of 121 is 11. Then the square root of 125 can be split up into the square root of 5 and the square root of 25, which is plus or minus 11 over 5 root 5, and we can rationalize the denominator in the same way. Now, for this question, you don't need to justify why it's the plus version, but I'll do a quick explanation. This is the cos graph here, and in the previous part, we were given that cos is negative. Cos is negative, then it's going to be between these two values here, which is between 90 and 270. And if I draw a quick sketch of the sine graph, which is like this, if we try and match it up, we'll be able to work out if it's positive or negative. Using the diagram, we can see that it's an obtuse angle, so that means it's in the first half of the negative bit, which means it matches up with the positive half of the sine, so sine of A will be in fact positive. So 11 root 5 over 25. But as I say, you don't need to justify it to get the extra mark in this question. So for part C, we're looking for the area of the parallelogram, and the area of the parallelogram is going to be 2 times the area of the triangle. That's the triangle OAB. When you see the area of a triangle, it should immediately make you think half AB sine C. And in this case, A is OA and B is OB, and then sine is sine of the angle. Hence why they got us to do part B, because that's going to be helpful for part C. 2 times a half is just 1, so I'll leave that off. The size of OA was root 20 from before. The size of OB was root 25, or just 5. And then the sine of the angle, we just copy and paste the number there in part B, so that's 11 root 5 over 25. Now it's just a case of simplifying. So we know that root 20 is 2 root 5, we did that before. We know that 25 square rooted is 5. Now if we work this out, root 5 times root 5 is 5, and then 5 times 5 is 25, so all these 5s disappear. Boop, 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 boop. And the final answer, 2 times 11, which is 22. How lovely. And a bonus reason that it should be positive from above, the area needs to be positive. So the sine should be positive. And here are 2 more.